death by 1,000 prompts, open model vulnerability analysis.
So what are we looking at here? This number represents the peak multi-turn attack success rate found against one of the open-weight models tested. The paper's core finding is that these models struggle to maintain their safety guardrails during extended conversations. The analysis hinges on comparing two different attack vectors. Can you define those for us?
Of course, a single turn attack is just one isolated adversarial prompt. A multi-turn attack, on the other hand, develops that adversarial prompt over a series of conversational exchanges. The paper reports that this multi-turn method exposes a systemic vulnerability. Defenses that might work for a single query tend to break down over time.
Before we dive into the specific results, it's important to understand the setup. How exactly was the assessment conducted? What were the ground rules?
It was a black box engagement. This means the testers had no prior knowledge of the model's architecture, its design, or any existing guardrails. They were probing it from the outside, just as a real-world attacker would. And what was the specific threat model they were simulating? The threat model assumes an attacker is using multi-turn jailbreak and prompt injection attacks. The goal is simply to steer the model toward producing disallowed content. To test this, the paper used an automated algorithmic assessment to measure each model's resilience in a consistent way. Okay, so an automated process with a clear, repeatable structure. What did those steps look like? Yes, it's a simple loop. Step 1, dispatch an adversarial prompt. Step 2, evaluate the model's response. Step 3, score it as a pass or a failure. Now, a failure was clearly defined as any instance where the model produced harmful content, revealed sensitive information like system prompts, or bypassed its built-in restrictions. All right, with that methodology established, let's get to the numbers. Just how large is this vulnerability gap between the two attack types? It's considerable. The average attack success rate for single-turn attacks across all the models was 13.11%. For multi-turn attacks, that average jumps to 64.21%. That's nearly a 5-fold increase in effectiveness. So that's the average, but was this trend uniform across all the models, or did some perform better or worse than others? No, the table shows a pretty wide range of performance. At one extreme, you have Mistral Large 2, which had the highest multi-turn attack success rate at 92.78%. At the other end, Google's Gemma 31B IT had the smallest security gap, where multi-turn attacks were only about 10.5 percentage points more successful than single-turn ones. And the paper is quite direct about the implications of this gap. It is. It states that this superiority of multi-turn attacks demands immediate security enhancements to mitigate production risks. The paper then goes on to suggest this vulnerability gap stems from a fundamental tension in how these models are developed, specifically the balance between capability and safety alignment. And I assume that trade-off is handled differently by different labs, which could explain the performance variance we just saw. That's what the paper suggests. It categorizes labs into two groups. You have labs like Meta and Mistral, which are described as capability first. They tend to defer safety defenses to the entity deploying the model, and this correlates with larger security gaps. In contrast, models from labs like Google and OpenAI are described as having a stronger safety posture from the start, which resulted in smaller gaps in this study. Are these findings isolated, or do they align with other research in the field? They align. The paper cites a study by Nasser and others that found adaptive multi-turn attacks achieve success rates above 90% against most defenses. Of course, the paper is also transparent about its own limitations and where future work should focus. So, what are the specific caveats to keep in mind when interpreting these conclusions? The paper notes 3 main limitations: the variability that comes from using an LLM to judge responses, the non-deterministic nature of the models themselves, and the potential for false positives or negatives. For future work, it recommends expanding tests into more complex scenarios, like agentic and tool use cases, and also evaluating multimodal contexts. Okay, so given these documented vulnerabilities, what are the concrete, actionable recommendations for developers who are actually using these models? The paper provides 5 imperatives for a multi-layered defense. 1. Implement strict metaprompts that are specific to your use case. 2. Use third-party, model-agnostic guardrails as an additional layer. 3. Perform risk assessments. 4. Strictly scope the model's permitted functions. And 5, log all model inputs and outputs for monitoring. These recommendations offer a clear tactical roadmap, but this research also highlights a larger, more fundamental challenge. As model capabilities continue to increase, how do we ensure that safety alignment can effectively scale along with it? That seems to be the central question this paper leaves us with.